Hey, welcome to the Explainer. For as long as we've been around, we've looked up at the night sky and just wondered. Today, we're going to explore that journey, from our ancestors' very first star charts to the most powerful telescopes we've ever built. We're breaking down how we read the stars. And really, it all boils down to this one simple question. It's the engine that drives every single discovery. And the answer? It's found in our most powerful toolkit, science. Science isn't just a pile of facts, it's a process, a way of building reliable knowledge about the incredible universe all around us. Okay, so before we even get to the stars, we've got to talk about the ground rules. Our journey really begins with the foundational principles we use to discover, well, anything at all. Think of this as the basic roadmap for discovery. It's a loop that makes sure what we learn is systematic, not just some lucky guess. You start with a question, you make a prediction, and then you test it. But it doesn't just stop when you analyze the data. The most crucial step is actually communicating what you found, so the whole world can learn and build on it. Now, while we're investigating, it is so important to know the difference between what we see and what we conclude. An observation is just what you can directly notice. The sky is dark. Simple, that's an observation. An inference is the logical leap you make from that. Why is it dark? We infer it's because our little spot on Earth has spun away from the sun. Science is all about linking those solid observations to really good inferences. All right, this is something that trips a lot of people up. A scientific law just describes what happens. You drop an apple, gravity pulls it down, every time. But a scientific theory, that's our best explanation for why it happens. So one predicts the event, the other explains the whole mechanism behind it. And here's the thing, and it's super important. No discovery ever happens in a vacuum. Science is a massive, global team sport. Every new breakthrough is literally standing on the shoulders of all the research that came before it, often from completely different fields. It's like this giant collaborative puzzle we're all solving together. Okay, now that we've got the rules of the game down, let's start playing. Let's apply this toolkit to our very own cosmic backyard, the incredible clockwork system of our sun, Earth, and moon. This cosmic dance between our planet, the sun, and the moon is actually pretty simple, but wow, it creates the most fundamental rhythms of our entire lives. Everything on this list, from the daily cycle of light and dark to the amazing spectacle of an eclipse, it's all just a direct result of where these three are in relation to each other. So predictable. So our little neighborhood makes sense, but figuring out our place in the wider solar system, whoa, that was a huge challenge. It actually required a complete rewrite of our cosmic map, and it was all driven by new, world-changing evidence. I mean, for more than 1,000 years, it just made sense to think everything revolved around us. The geocentric model seemed to fit what people could see with their own eyes. But then, as our tools got better, the evidence just stopped fitting. The math didn't work anymore, and these new observations paved the way for the heliocentric view we have today, with the sun right at the center. And this is the absolute key takeaway right here. Science isn't some dusty old book of facts that's set in stone. It's a living, breathing process of refinement. As we get more data and make better observations, our models of the universe have to evolve to give us a clearer, more accurate picture. But that begs a really important question, doesn't it? Was it just a story of Western thinkers? Absolutely not. The real story of astronomy is so much bigger and older, and long before telescopes, other powerful systems of knowledge were already reading the sky with incredible sophistication. So now, let's turn to the incredible, deep astronomical knowledge of Aboriginal and Torres Strait Islander peoples. We're talking about the world's first astronomers, with an understanding of the sky that's been passed down for tens of thousands of years. See, this wasn't just abstract knowledge, this was science for survival. For instance, the Burung people in Victoria, they knew that when a certain constellation, which they saw as a malleefowl, appeared in the sky, well, that was the signal. It was time to go and collect the bird's eggs. This wasn't just stargazing, it was a complex calendar linking the stars to weather, animals, and plants, a system perfected over millennia. And that, right there, brings us completely full circle. From the earliest human observations of the night sky, we've pushed all the way to the absolute pinnacle of our scientific and collaborative efforts, the most advanced tool for observation humanity has ever built. I mean, look at the James Webb Space Telescope. It is the ultimate expression of that whole scientific toolkit we've been talking about. It's this massive international project, a high-tech eye in space designed to see the universe in ways we could never even dream of from the ground.
So what's its mission? Well, it's to help answer those same giant fundamental questions we started with. By looking at things at the very edge of space and time, it's gathering data on everything from the air on distant planets to the birth of the very first stars. It's literally looking back to the dawn of the universe itself.
It's incredible when you think about it. From the very first star charts drawn in the sand to these breathtaking images from deep space, our whole view of the universe has changed over and over again. It really makes you wonder, doesn't it? With every new eye we point toward the sky, we rewrite the story of the universe. What will the next chapter reveal?